Hey everyone, so today we're going to be talking about piecewise functions. Now this is a definition that you may need to know for tests. So basically a piecewise function is a function that is defined by multiple subfunctions. So like these three subfunctions, and each subfunction goes with a specific part of the domain, okay? So this function is the piecewise function defined by these three functions that go with this domain. So how do we find these values? So f of -2 will start here. So our x is -2. So we go here to our domain, and where does -2 fit in? So it'll be this one, x less than or equal to 0. So we're going to plug in -2 here. So -2 squared, 4 minus 1, 3. Okay, our next one is 0. Well, we have zeros both here and here, so we're going to go with the one that's equal to. Okay, so 0 minus 1, -1. All right, 3. So 3 is between 0 and 5, so we'll go here. 2 times 3, 6, minus 1, 5. What about 5? All right, so we have the 5s here, but this one's the only one that's equal to. So 2 times 5, 10, minus 1, 9. And last, f of 10, which will go with x is greater than 5, and that is just 3. And that's it. Okay, so now how do we graph these? Okay, so first you're going to do a grid with vertical asymptotes. Okay, and your vertical asymptotes are going to be these right here. So if we were going to graph this, we would have a vertical asymptote at 0 and 1 at 5. All right. So start with that. Number 2, I start on my furthest one, okay, on my furthest vertical asymptote, and plug that in. So furthest meaning leftmost function. Okay, start with that and work to the left because you're going to the left of that vertical asymptote. Leftmost function and go left, and just get a couple of points. You don't need to do too many. All right, number 3, then you just move on to the next function and its domain. Repeat as necessary, and then you have your graph. Now, the biggest thing that you need to be concerned about is if this is equal to or not equal to, because if it's greater than or less than or greater than, the point is open. So it looks like this, what we look like as a whole. Okay, so it's open. All right, let's do an example. All right, so we're going to start with our grid. Okay, our vertical asymptote is just going to go at 0 because we only have one division. Okay, let's make some points. Okay, so again, start with your leftmost function, which is going to be this one. It's usually the top one. So, and it is less than or equal to and 0. So when you plug in 0, you get 2. And then it's a straight line at y equals 2. Okay, we'll go back to 0 and plug in 0 here. If we plug in 0, we get 2 again, even though it's not equal to, at least it's filled in from the previous function. Okay, now plug in 1, so that would be 3. Plug in 2, 4, 5, 6. And fill in your graph. And there you go. That's your piecewise function. Now, if you'll notice here, we did have where it lined up, both of these endpoints ended up meeting, okay? This is what we call continuous. Okay, when both endpoints meet and you don't have to take your pencil off the page, it's called a continuous function. Now, discontinuous is when those two endpoints don't meet, okay? So something like it goes like this, and that line was down here, okay? So here are going across the domain, we were going to this function, and then we had to take our pencil off and put it back here to finish off the function. This is an example of discontinuous. Okay, so here's our next piecewise function example. So we've got some pretty big functions going on here. So we're going to use our calculator and use it to help us find some points pretty quickly. Okay, so again, the first thing we're going to do is vertical asymptotes. So we have one at -4. And one at 1. Okay, now let's grab our calculator. Okay, so log -x plus 3 plus 1. Okay, so you'll notice this function starts at -4 and goes to the left on the domain. So once it finishes, we'll go to trace and plug in -4, and we get 1. So -4, 1, 2, 3, 4, and +1. Okay, now let's get another point, because we can see it goes off like that. But let's see, -5, -6. Okay, so it just stays here and it goes very short. Okay, now what about our next one? Okay, so we'll notice we also have vertical asymptotes at -4 and 1, okay? And this graph goes right in between. So let's do trace. Okay, 0.25 is one of our points. Okay, let's find the x-intercept. Oh, there we go. So our x-intercept is -1. Okay, and it goes up, crosses, and then comes down. All right, now our next one I think we can do without a calculator. So it's equal to at 1. Oh, and that's one thing I forgot to mention. Since this is equal to, then we can fill it in. If it isn't, we just leave it open. Plug in a 1, so 1 would be 2. 1, 2. And now the slope is 2, so rise 2, run 1. And make a straight line from there. And there you have your piecewise function. Okay, so this first one, something is sold such that the more you buy, the lower the price goes. So if you buy 20 or fewer items, it's $5 per item plus a $10 fee. If you buy over 20, it's going to be $4 per item plus a $30 fee. So what is the max number of items you can purchase with $170? All right, so first let's look at the different formulas. So this one, f of x is $5 per item, so 5x plus the $10 fee. And that domain is going to go between 0 and 20. Okay, with this one, it's $4 per item, but a $30 fee. And that's if x is greater than 20. Okay, so how many items can you purchase with $170? Well, first we're going to need to find the y value of these for their endpoints. Okay, So let's plug in 20 for this one. So f of 20 would be 110. And if we plug in 20 here, it would be 110 as well. But we're looking at spending $170. So since 170 is greater than, we know we're going to use this second formula. So we're going to put 170 is equal to 4x plus 30. Subtract the 30 over and divide by 4. So 35. So you could get 35 items for the $170.